My name is Venkat MD, Director of Time Institute Tirupati. So, in this video I will discuss with you find the number of zeros at the end of the product 100 factorial. Find the number of zeros at the end of the product 100 factorial. So, it is the previous CAT question. So, in 100 factorial means suppose 1 into 2 into 3 into 4 into 5 into and so on up to infinity, up to 100. 100 factorial means 1 into 2 into 3 into 4 into up to 100. So, in this entire product, in this large product at the end, how many zeros are there? Number of zeros you got. But how can you calculate exactly how many zeros are there at the end of the product it is? Okay. A simple logic is there. By using that logic, we can calculate the number of zeros at the end of the product it is. Okay. What is our question? Find the number of zeros at the end of the product 100 factorial. So, listen to me carefully. What is the concept of number of zeros at the end of the product? Okay, when you got 0 at the end of the product, see here, if there is 1, 2 and 1, 5 is there, if there is 1, 2 and 1, 5 is there, you get 1, 0. In the product, if there is 1, 2 and 1, 5 is there, we get 1, 0. 2 into 5 is 10. If it is to be considered as one pair, from one pair we get 1, 0. Suppose let it be there are two pairs, it is just like 2 square into 5 square it is. 2 square into 5 square. Mean there are two pairs it is. So 2 square is 4, 5 square is 25, 25 into 4 is 100 here. So 2 zeros at the end of the product. Suppose there are two pairs, there are 2 zeros at the end of the product it is. Similar way, let it be suppose there are 3 pairs it is, suppose 2 cube into 5 cube. 2 cube into 5 cube, 2 cube is 8, 5 cube is 125, 125, 8 is 1000 it is. 1000 means how many zeros? 3 zeros. So 3 pairs, there are 3 zeros. So the number of pairs gives the number of zeros at the end of the product. The number of pairs gives the number of zeros at the end of the product. Let it be in the given product 100 factorial means 1 into 2 into up to 100. You have to identify only 2's and 5's. The remaining digits we do not require. So, suppose let it be 3, 3 into 3 into if you can multiply infinite number of times you do not get 0 at anywhere. Suppose only 5 is there, 5 into if you can multiply infinite number of times you do not get 0 at anywhere. Suppose 7 into if you can multiply infinite number of times you do not get 0 at anywhere. If there is 1, 2 and 1, 5 is there, so you get 1, 0. If it is to be considered as one pair, 2 and 5 is to be considered as one pair. So, from one pair we get 1, 0. So, the number of pairs gives the number of zeros it is. Let it be in the product 100 factorial, we do not know how many 2's are there, how many 5's are there, that you have to identify first. How many 2's are there, how many 5's are there, how many pairs we can make, that pairs gives the number of zeros at the end of the product. Let it be in the given product, 2's let it be 40, 2's let it be 40, 5's let it be only 30. So, how many pairs you can make from this? 2's let it be 40, 5's let it be 30. 1, 2 and 1, 5 make it as one pair it is, 5's only 30 are there. 2's also you have to consider only 30. 2's also you have to consider only 30. Why? 5's are 30, 2's also 30. So, 30 pairs we can make it is. Means in the power, the least power gives the number of pairs. 2's 40 are there, 5's 30 are there. How many pairs we can make means what is the least power in these two? 30. So, we can make 30 pairs. So, how many zeros at the end of the product means you have to say 30 zeros at the end of the product it is. So, the number of pairs gives the number of zeros it is. So, in the given product you have to identify only 2's and 5's. So, from 1, 2 and 1, 5 make it as one pair, from one pair we get 1, 0, the number of pairs gives the number of zeros. How can you make the pairs also? If you identify 2's and 5's, the least power. So, 2 power here 40, 5 power 30, which is the least power 30. So, 30 pairs you can make, so 30 zeros at the end of the product. Now, similar approach we follow for 100 factorial also. Here 100 factorial means, see here 100 factorial means So 1 into 2 into 3 into 1 into 2 into 3 into 4 into and so on. So 98 into 99 into 100 it is. Okay, 100 factorial means 1 into 2 into up to 100 you have to multiply. But in this product you have to identify how many 2's are there and how many 5's are there. In these two again 2's and 5's you have to identify only least number. Why we identify only least number? The least number gives the number of pairs it is. The least power gives the number of pairs. Which is the least power means the least number. Which are in less number in this 100 factorial, tell me. Which are in less number? Either 2's or 5's, tell me which are in less number. If you observe 2, in every even number 2 is there. In every even number 2 is there. 2, 4, 6, 8, 10, 12, 14, 16 and so on. So in every fifth number only 5 is there. In every fifth number only 5 is there. So 5, 10, 15, 20, 25 and so on. So in these two which are in less number, either 2's or 5's. So clearly we say 5's are very less number. Very less number. Why? In every fifth number only 5 is there. So 5, 10, 15 and 20 and so on. So in 100 factorial you have to identify only how many 5's are there. We don't require 2's. Why? Which are in less number, that you have to identify. That gives the number of pairs. Number of pairs gives the number of zeros at the end of the product. That is our logic. So in this 100 factorial you have to identify only 5's it is. How many 5's are there it is. So practically if you calculate, so 5's, so 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, so 95, 100. So in every fifth number, so 5, 10, 15, 20 and so on up to 100. Now count in this how many 5's are there. Okay. Now by observing here in the last numbers 25, 50, 75 and 100, in 25, 50, 75 and 100, if you consider this, in 25 how many 5's are there? 2 5's, 5 square it is. In 50 also how many 5's are there? 2. Why? So 50 can be written as 25 into 2. In 25 again, so 2 5's are there. In 75 also how many 5's are there? 2 5's are there. Why? It can also be written as 25 into 3. 25 into 3. So 25 means again how many 5's are there? 2. Now 100 can also be written as 25 into 4. 100 also can be written as 25 into 4. 25 into 4 means 25 means again how many 5's are there here? 2 5's are there. So in 25, 50, 75, 100, 2 5's are there. In the remaining numbers only 1 5 is there. Now count how many 5's are there here. Suppose 5, 10, 15, 20, 4 by 4 it is 16, 16 plus 8 it is. So 5 power 2, 5 power 2, 5 power 2, 5 power 2, total 8 are there. So 16 plus 8, how much it is? 16 plus 8, so 24, 5's 24 are there. So in 100 factorial, if you identify how many 5's are there, 24 5's are there it is. Suppose you identify 2's, you get more number of 2's. Why? In every even number 2 is there. 2, 4, 6, 8, 10, 12, 14 and so on. In 16 itself, only in one number 2's 4 are there. In 32 itself, how many 2's are there? 5 2's are there. In 64, one number itself, how many 2's are there? So 6 2's are there. Just like if you get more number of 2's. So we require here the less number, which are in less number, 5's are in less number. So how many 5's are there in this product now? 24 5's are there in this product. So let it be 2's or x, 2 power x, x definitely greater than 24. X definitely greater than 24. So which are in less number, 5's are in less number. Least power gives the number of pairs, already I told you. So which is the least power in these two? 5 power 24 into 2 power x it is. Okay, 5's 24 are there. 5's 24 are there. Let it be 2's are only x. x definitely greater than 24. So, which are in less number? 5s are in less number. So, which is the least power here? 24. So, how many pairs we can make here? Clearly we say 24 pairs we can make here. So, 24 pairs means at the end of the product, how many zeros are there at the end of the product? So, 24 zeros at the end of the product. So, we say 24 zeros at the end of the product it is. Okay, but here after writing and counting we say how many 5s are there. After writing and counting we say 5s 24 are there. But without writing and counting, how can you say how many 5s are there? So, this is the general method. This is the general method to calculate the number of zeros at the end of the product. To find the number of zeros at the end of the product, immediately how to identify how many 2s are there, how many 5s are there. 1 2 and 1 5 make it as one pair. From one pair we get 1 0. The number of pairs gives the number of zeros at the end of the product. The number of pairs gives the number of zeros at the end of the product. Now, in these two again 2s and 5s, you have to identify only less number which are in less number, but in this 100 factorial 5s are in less number. So, need not necessary to calculate 2s, how many 2s are there? We require only less number which are in less number, 5s are in less number. So, you have to identify how many 5s are there in this 100 factorial. If you write 5, 10, 15, 20 multiples of 5 and count, you get 5s 24 are there. Let it be 2s or more number it is. So, how many pairs we can make? 24 pairs. So, you get 24 zeros at the end of the product it is. This is after writing and counting we say 5s 24 are there. But without writing and counting, how can you say 5s 24 are there? A very simple logic is there, very shortcut approach is there. I will tell you, I will explain that also. Without writing and counting, how can you say 5s 24 are there? Very simple logic is there. Okay, see here, what is that logic? Okay, in 100 factorial, listen to me carefully, how many 5s are there? We require only 5s it is. So, 100 divided by 5. So, what we do? 100 divided by 5 and you take only quotient. By dividing 5, what is the quotient? Quotient means how many times it is divisible. How many times it is divisible? That is called the quotient. So, 100 by 5. How much 100 by 5? 20. You take only 20. All of you understand that how can you get 20? 100 by 5. Why you take only 5? We require number of 5s. How many 5s are there in the product? 100 factorial, that we require. So, 100 by 5. So, by dividing 5, what is the quotient here? 20 is the quotient. Again this 20 divided by 5. Again you calculate the quotient. So, 20 by 5. Again 20 by 5. How much quotient? 4 it is, plus 4. Plus 4. This you have to calculate up to less than 5. So, here 4 you got less than 5 it is. Now, again 4 divided by 5, what is the quotient? 0 is the quotient. So, need not necessary to take again plus 0, plus 0, plus 0. So, you have to calculate up to less than 5. So, 4 is less than 5. So, up to enough. Okay. Now, 20 plus 4, how much it is? 20 plus 4? 24. So, get how many 5s are there at the end of the product? 24 5s are there at the end of the product. So, how many zeros at the end of the product now? 24 zeros at the end of the product it is. So, in this way you have to calculate. Okay. So, any number of factorial is given, not only 100. All of you understand this? How can you get this? 100 by 5, by dividing 5, 20 is the quotient. Again 20 by 5, 4 is the quotient it is. Up to less than 5 you have to calculate. So, 4 is the less than 5. Now, take the sum of these two, 20 plus 4, 24. So, how many 5s are there? So, 24 5s are there in the product 100 factorial. So, 24 pairs we can make. So, how many zeros at the end of the product? So, 24 zeros at the end of the product it is. Suppose I will give one more example. It is actually previous CAT question. In 100 factorial, how many zeros are there at the end of the product it is. Okay. Not only 100 factorial. So, any factorial is given. By using this logic, you can calculate the number of zeros at the end of the product it is. Suppose let it be another examples, let it be 250 factorial. In 250 factorial, find the number of zeros at the end of the, see here, in 250 factorial, find the number of zeros at the end of, so 250 factorial it is. Find the number of zeros at the end of 250 factorial it is. Okay, 250 factorial. So, apply the same logic, you have to identify only 5s. How many 5s are there in 250 factorial? What is our logic? 250 divided by 5. By dividing 5, you have to take only quotient it is. Quotient means how many times it is divisible, that is called the quotient. So, 250 by 5. By dividing 5, how much you got? 50. 50 is the quotient. Again this 50 divided by 5 again. 50 divided by 5. By dividing 5, how much you got? 10. 10 is the quotient again. Again this 10 divided by 5. This 10 divided by 5. What is the quotient again? 5 2s it is 2. So, less than 5 you got. Up to less than 5 you have to calculate. So, 2 is the less than 5. Now, take the sum of all this, how much you got? 62. So, in 250 factorial, how many 5s are there? 62 5s are there. So, we make 62 pairs. So, how many zeros at the end of the product means you say? So, 62 zeros at the end of the product. So, 250 factorial. Just like any value be given. So, observe one more example. So, find the number of zeros at the end of the factorial at the end of 175 factorial. 175 factorial. 175. Okay. Find the number of zeros at the end of the product 175 factorial. Now, see here what we do. So, here also we follow the same logic. So, by dividing 5 and take the quotient it is. So, 175 by 5. By dividing 5, what is the quotient here? So, 5 3 is a 15, 5 5 is a 75, okay, 35. By dividing 175 by 5, what is the quotient here? 5 3 is 15, 25, 5 is 5 is a 25, 35 is the quotient. Again 35 divided by 5. So, what is the quotient? 7 is the quotient. Again 7 divided by 5. By dividing 5, 5 1s it is. So, 1 is the quotient. Do not bother about remainder. Here you have to consider only quotient. You consider only quotient, you take only quotient it is. So, 7 divided by 5, how many times it is divisible? So, 1 time it is. So, 5 1s are 5. So, 1 is the quotient it is. So, we get less than 5 it is. Now, stop up to that and take the sum of all these. So, 35 plus 7, 42 plus 1, 43. So, how many 5s are there? In 175 factorial, so 43 5s are there, 5 power 43. So, how many pairs you can make here? So, 43 pairs. So, how many zeros at the end of the product now? So, 43 zeros at the end of the product it is. So, 43 zeros at the end of the product. Just like any factorial is given, you can calculate the number of zeros at the end of the product. Let it be another example. So, 234. So, find the number of zeros at the end of the product 234 factorial, 234 factorial, 234. Here also we do the same thing. So, by dividing 5, quotient you have to take. By dividing 4, 5, 5 4 is 20, 5 6 is 30 it is. So, what is the quotient? 46 is the quotient. By dividing 5, you have to consider only quotient, how many times it is divisible? 5 4 is 20, 5 6 is 30. Okay. Now, again 46 divided by 5, you observe only quotient it is 5 9s are 45, 9 is the quotient it is. Now, again 9 divided by 5, you have to observe only quotient, how many times it is divisible? By dividing 5, 5 1s are 5 it is. Okay, you get less than 5, up to less than 5 you have to calculate. Now, take the sum of all this it is. So, 9 plus 1 10 plus 46 56 it is. So, how many 5s are there? So, 56 5s are there at the end of the product it is. Okay. So, 5 56 means how many pairs you can make? 56 pairs you can make. So, how many zeros at the end of the product? Very good. Clearly, we say 56 zeros at the end of the product in, so 234 factorial, just like any factorial is given. So, by using this logic, we can calculate the number of zeros at the end of the product. Okay. This type of questions are asking in, so CAT, MAT, ZAT, IPSAT, ZMAT. So, national level MBA entrance examinations. Okay. So, these type of questions are asking in national level MBA entrance examinations it is. Okay. Okay. Thank you to all of you. Again, I will come with a new concept. Okay.